Have you ever heard the story about Isaac Newton and the falling apple? It's a classic. One day, so the story goes, Newton was sitting under an apple tree when an apple fell and bonked him on the head. Now, whether it actually hit him or just fell nearby, that simple event sparked one of the greatest scientific questions of all time. If an apple falls, does the moon also fall? This seemingly simple question led to a revolutionary idea, the law of universal gravitation. So, what is this law exactly? It's actually quite elegant. Newton proposed that every single object in the universe, from the tiniest grain of sand to the most massive star, pulls on every other object. This pull or force is what we call gravity. The strength of this force depends on two things. First, the mass of the objects. The more massive the objects are, the stronger their gravitational pull on each other. That's why you feel Earth's gravity so strongly. It's massive. Second, the distance between them. The farther apart the objects are, the weaker the force becomes. Specifically, the force decreases with the square of the distance. Meaning, if you double the distance, the force becomes 4 times weaker. The real genius of Newton's law was its universality. It wasn't just a rule for things on Earth. It was a rule for the entire cosmos. The same force that pulls an apple from a tree to the ground is the very same force that keeps the moon in a constant state of falling around the Earth, creating its orbit. It's also the force that keeps the Earth orbiting the Sun, and the Sun orbiting the center of our Milky Way galaxy. For the first time in history, one single, beautiful mathematical law could explain the motions of both celestial bodies and terrestrial objects. The heavens and the earth were united under one set of rules. Now, fast forward a couple of 100 years, and another genius named Albert Einstein came along. With his theory of general relativity, he gave us an even deeper understanding of gravity, describing it as a curvature of spacetime caused by mass and energy. But here's the amazing part. For almost every practical purpose, from launching satellites to calculating the trajectory of a baseball, Newton's law is still incredibly accurate and much simpler to use. It remains one of the most important cornerstones of classical physics. So the next time you see something fall, remember the incredible journey of that idea, from a simple apple to the grand dance of the cosmos. Thanks for watching, and don't forget to like and subscribe for more amazing science stories.